We're now going into the heart of Iceland, to the eastern rift zone. Now, one pronounced difference is that the western rift zone is continuous with the offshore spreading ridge, whereas the eastern rift zone is not, because of a transform fault zone. So let's now look at how basalt volcanism is organised in the eastern rift zone. Fissure swarms in the eastern rift zone are different to those in the western rift zone because they are always connected to a central volcano. A central volcano is a volcanic structure beneath which is a magma chamber that traps basaltic magmas as they ascend from the mantle. In Iceland, a central volcano plus its 1 or 2 fissure swarms is called a volcanic system, and this map shows the volcanic systems in the eastern rift zone. But we're only going to examine one of these. This is the Barðabunga central volcano and its fissure swarms. So let's now spend some time looking at one eruption in detail, the 1480 AD eruption from Barðabunga's southwest fissure swarm. Well, behind me here we have a large central volcano under the ice. This is called Barðabunga, and its fissure swarm to the southwest is called Veiðivot, and that's where we're going to next. This is the youngest basalt eruption in this fissure swarm. It happened in 1480 AD. It started life under a central volcano some 70 kilometres to the northeast, and it continues for another 30 kilometres to the southwest. A chemical analysis of the basalt in this 1480 AD fissure eruption shows it to be a quartz tholite. In fact, a great many of the basalt eruptions in the eastern rift zone are quartz tholite. Now, let's move to where this quartz tholite fissure stopped, at the Torfajökull volcano. We're now near the southwest end of this youngest basalt fissure eruption, and here the erupting fissure has met water and has reacted violently to produce this large explosion crater. As we move further to the southwest to the very end of the fissure, we will find features that will help to link this single eruption to the large-scale processes that have created Iceland. Through the valley is the large basaltic explosion crater we've just come from. A little further down the fissure we have another basaltic explosion crater, this time a little bit smaller. But over here, flowing down into the lake, we have something quite different. This is a rhyolite lava flow. Let's go down and take a look at this rhyolite lava flow. Rhyolite is a rock much richer in silica than basalt, and it produces much thicker lava flows. Its importance is simply that it has different physical properties to basalt, so when basalt meets rhyolite, there's some characteristic features that can be observed in the field. This rhyolite lava flow is about 4 times my height. But if we look over there, we can see another rhyolite lava flow that dwarfs the tents and vehicles at its foot. These rhyolite lava flows were erupted at the same time in 1480 AD. That's the same time as the basalt fissure to the northeast of here. Here's a rhyolite from this flow. Let's look at what's in it. First of all, I note that there are small grey inclusions. These are actually basalt. What interests me is the wispy nature of a contact between the basalt inclusion and the rhyolite. This tells me that the basalt and the rhyolite must have been molten when they were mixed together. Now there's 5 times as much basalt in this rhyolite as there is in the thicker flow. And the thicker flow is really where the basalt fissure ended. Let's try and put this evidence together and see what it tells us about the bigger picture. We have a basalt eruption started under the Barðabunga central volcano, continued through Veiðivot, and here it encountered a rhyolite magma chamber under the Torfajökull volcano. Now this hasn't just happened in isolation, it's happened 5 times in the last 5,000 years. That's a remarkable change in the behaviour of the Torfajökull volcano. Now what this is telling us is that the entire rift zone, the entire eastern rift zone, is migrating towards the southwest. This is a major change in the dynamics of the Icelandic rift system.